Dear students, we are starting with the trigonometric identities. What is an identity actually? An identity is an equation that is true for all the variables. As for example, if I take the traditional formula x plus y whole square, and it is equal to x square plus 2xy plus y square. You may take any value of x and y. As for example, we take say x is equal to 1 and y is equal to 0. So you put on LHS, you will find 1 plus 0 and its square means 1, and RHS will be 1 square plus 2 into 1 into 0 plus 0 square. So again you are getting 1. So the results are same, 1 and 1. So since LHS and RHS are equal, that means x and the values of x and y are satisfy this identity. Also you may take any other value, whatever you want to put. Say x is equal to minus 1 and y is equal to say 2, such that on LHS you are getting it as minus 1 plus 2 whole square. So 1 square is equal to 1, and put these values on RHS also. So this is minus 1 whole square plus 2 into minus 1 into 2 plus 2 square, and getting it as 1 minus 4 plus 4. 4s are cancel, only 1. So it is an identity actually. Whatever you take the values of x and y from the real line, and these values will obviously satisfy the identity x plus y whole square is equal to x square plus 2xy plus y square. But in an equation you will find a definite value. As for example, if you take twice x is equal to 4, then x is equal to only 2, 4 upon 2, so you are getting 2 only. Except this value 2, you can't satisfy this equation. Twice x is equal to 4. As for example, if you take any other value, say x is equal to 3, so your LHS is equal to 2 into 3, so this is equal to 6, but 6 is not is equal to 4, that is your RHS. So LHS is not is equal to RHS. So except these two, you can't put on its left side so that you get the right side. So this is an equation, but the left one is an identity. So now similarly, in an equation involving trigonometric ratios of an angle is called a trigonometric identity if it is true for all values of the angles involved. So we start the trigonometric identities. So let us consider that it is the triangle ABC. Okay, ABC, right angled at B. Let us consider the side measures be respectively. Say this is P, this one is Q, and it has R units. Okay, so it is an isosceles, it is a right angle triangle. So from this triangle you can put R square is equal to P square plus Q square. It is a right angle triangle, right angled at B. The side measures are taken as PQR. So using Pythagoras theorem, you can write R square is equal to P square plus Q square, mark it 1. Okay. Also sin theta, if you take angle A as theta, okay, theta is an acute angle. So sin theta, what is sin theta? Sin theta is equal to P divided by R. Cos theta is equal to Q divided by R, and tan theta is equal to perpendicular divided by base P upon Q. So their reciprocals are respectively cosec theta is equal to R by P, sec theta is equal to R by Q, and finally cot theta is equal to Q by P. Okay, 6 basic ratios are found, trigonometric ratios are found. Now if you square and add the first two, sin theta and cos theta, then what will you find? Okay, suppose sin square theta plus cos square theta. Just add squaring and adding. Okay, the first two, sin square theta plus cos square theta. So that on the right side also you will get, okay, I write it here. This is p square upon r square plus q square upon r square. Take an LCM here, r square, so p square plus q square. Now what is p square plus q square? P square plus q square, it is found equal to r square. So substitute, you will find r square upon r square. R is not is equal to 0, so you can cancel and getting 1. That means sin square theta plus cos square theta is equal to 1. This is the first identity. I shall write 1 by 1 at last, but before that we discuss about these identities. Now what is tan theta? Tan theta is equal to p upon q. Tan theta is equal to p upon q, right? Tan theta is equal to p upon q. So squaring both sides, you will get tan square theta is equal to p square upon q square. Now adding 1 to both sides, 1 plus tan square theta is equal to 1 plus p square upon q square. Make an LCM here. So it is q square plus p square. What is p square plus q square? P square plus q square is equal to r square according to equation number 1. So substitute p square plus q square is equal to r square upon q square. Okay, so this is r upon q whole square, Now what is r upon q? R upon q is equal to sec theta. It is sec theta. Okay, so you can substitute this r upon q. So you will get here sec theta whole square. So write it here. Sec theta whole square. So you can write sec square theta. Okay. The last one is from cot theta. What is cot theta? Cot theta is equal to q upon p. So square this, you will get cot square theta. Cot square theta is equal to q square upon p square. Now add 1 to both sides, so that you will get 1 plus cot square theta is equal to 1 plus q square upon p square. Make an LCM here. p square plus q square. Now what is p square plus q square? Again, according to 1, you can substitute r square upon p square. So it is r upon p whole square. Now what is r upon p? R upon p is cosec theta. This is here. R upon p is equal to cosec theta. So substitute cosec theta and its square. So you will get cosec square theta. Now 3 basic identities are found. I write 1 by 1. First identity is sin square theta plus cos square theta is equal to 1. This is the first identity. Next identity is 1 plus cot square theta is equal to cosec square theta. And the last one is 1 plus tan square theta is equal to sec square theta. Again, sin square theta plus cos square theta is equal to 1. Next, 1 plus cot square theta is equal to cosec square theta, and 1 plus tan square theta is equal to sec square theta. You may arrange in this way also. Sec square theta minus tan square theta is equal to 1, or cosec square theta minus cot square theta is equal to 1. Or you may arrange in different ways. Say sin square theta is equal to 1 minus cos square theta, or cos square theta is equal to 1 minus sin square theta. From the second one also, cot square theta is equal to cosec square theta minus 1. From the third one, tan square theta is equal to sec square theta minus 1. According to your need, you may use these 3 identities in different ways. And basic sum ratios also, I write the basic ratios. You have already found this in the previous chapter. First one was tan theta is equal to sin theta upon cos theta, and cot theta is equal to cos theta upon sin theta. So use these basic rules and you can solve the problems of your book. So we want to take few questions. First question is taken from your NCERT book. Prove that sec of a into 1 minus sin of a into whole into sec a plus tan of a is equal to 1. So it's LHS. Okay, LHS is equal to sec of a into, again write 1 minus sin of a whole into sec of a plus tan of a. Okay, so you can write sec of a as 1 upon cos of a, and it as usual 1 minus sin of a, no need to change sec of a, it is 1 upon cos of a plus this is sin a upon cos of a. Okay, so here 1 upon cos of a whole into 1 minus sin of a, and make an LCM here, it cos of a and 1 plus sin of a. So you may multiply 1 plus sin of a whole into 1 minus sin of a, that means 1 minus sin square a. What is the formula? The formula is a square minus b square. A square minus b square is equal to a plus b whole into a minus b, and cos of a into cos of a means cos square a. So write cos square a. And what is 1 minus sin square a? Because you know sin square theta plus cos square theta is equal to 1. So 1 minus sin square theta is equal to cos square theta, isn't it? Cos square theta is equal to 1 minus sin square theta. So you may replace the numerator and you will get cos square a whole divided by cos square a and equal to 1. It is your RHS. Okay, so in this way you can use the identities and will find the results very easily. These two questions are also taken from your NCERT book. Okay, so it's LHS. What is the LHS? Take the LHS. LHS is equal to cosec theta minus cot theta whole square, that is equal to 1 upon sin theta, because sin theta and cosec theta are reciprocal to each other, minus cot theta. Cot theta is equal to cos theta upon sin theta and its whole square. So make an LCM, sin theta 1 minus cos theta and whole square. So it is denominator a sin square theta and numerator 1 minus cos theta whole square. Well, what is sin square theta? Sin square theta is equal to 1 minus cos square theta, because you know sin square theta plus cos square theta is equal to 1. So sin square theta is equal to 1 minus cos square theta, and numerator as usual, don't change this 1 minus cos theta whole square, and break the numerator 1 minus cos square, 1 minus cos square theta, that means your denominator break this one, a square minus b square. So 1 plus cos theta whole into 1 minus cos theta, 1 minus cos theta. So numerator as usual 1 minus cos theta whole square. So you may cancel one of them, 1 minus cos theta is cancelled, so getting 1 minus cos theta whole upon 1 plus cos theta. Is it your right side? Yes, it is the right side. So the proof. Okay, next is this one. Okay, change the ink color. You take its LHS again. LHS is equal to cos of a. This is an interesting question. Cos of a upon 1 plus sine of A plus 1 plus sine of A upon cos of A. So make an LCM here. Again, cos of A whole into 1 plus sine of A and cos square A plus 1 plus sine of A whole square. Okay. So the denominator as usual, cos of A whole into 1 plus sine of A, and numerator will be broken. So cos square A as usual plus this one plus 2 sine A plus sine square A, okay, is equal to, what is the numerator? Sine square A plus cos square A is equal to 1. 1 plus 1 is equal to 2. So write 2 plus 2 sine A whole divided by the denominator as usual, cos of A 1 plus sine of A, and take 2 common. So 1 plus sine of A whole divided by cos A into 1 plus sine A. 1 plus sine A is cancelled. So 2 upon cos of A, that is equal to 2 sec A. So it's your RHS as the proof. Okay. So you have to take the last one. This is an important question. It comes in your exam actually. You take the RHS. The RHS is, from LHS it will be better. LHS is equal to cos A minus sin A plus 1 whole divided by cos A plus sin of A minus 1. Now watch carefully, on the right side there is cosec and cot. Okay, if it is cosec and cot, better you make this fraction in terms of cosec and cot. Again I discuss, the right side is in terms of cosec A and cot A, means cosec and cot. Cosec and cot, so the left side should be made in cosec cot. So what to do? You divide both numerator and denominator by sin A. Okay, sine of A whole divided by sine of A. Right, cos of A plus sine of A minus 1, and it is cos of A minus sine of A plus 1. Okay, so that you get here cos A divided by sine A, that is cot of A minus 1 plus 1 upon sine A means cosec A whole divided by cot of A plus 1 minus cosec A. Now your denominator will be left as usual, cot A minus cosec A plus 1. Okay, cot A minus cosec A plus 1, and this numerator will be adjusted, cot A plus cosec A. Okay, take it as usual, and this minus 1, that is okay, right, minus and 1, this one can be written cosec square A minus cot square A. Okay, cos, you know, 1 plus cot square A is equal to cosec square A. So cosec square A minus cot square A is equal to 1. Now this part is A square minus B square like this. So you can break A plus B whole into A minus B. Formula, you know, algebraic formula, x square minus y square is equal to x plus y whole into x minus y. Like this, you have to break this one. Okay, right. The denominator as usual, cot A minus cosec A plus 1, and numerator cot of A plus cosec A, and break this one, minus cosec A plus cot of A whole into cosec A minus cot of A, isn't it? So you may take cosec A plus cot A common. Okay, take cosec A plus cot A common. So that write it here, continuation. The denominator as usual, don't change, cot of A minus cosec A plus 1, and take cot of A plus cosec A common, and in bracket, another bracket, I will find 1 minus cosec A plus cot of A. Now see that something is common. 1 minus cosec A plus cot A, it is 1 minus cosec A plus cot A. So you can cancel these two. Okay, so that you are getting now cot A plus cosec A. And what is your RHS? Yes, it is your RHS. Cosec A, again right, cosec A plus cot of A, it's your RHS. So your proof is done. Okay, in this way you may use the trigonometric identities in proper place, and you will solve the trigonometric identities very easily, very frequently. And I think these examples and the basic concept of identities helped you. And in the next session we shall do many more problems. Till then, bye bye.